All right, so today we are going to talk about rough-in and how to do it correctly and the things to not forget. My name is Larry Davis. I am a super do-it-yourselfer, and we're going to talk about mechanical rooms. 100%, that's all I care about today. Mechanical room is one of the most important parts of your build. However, it's also one of the most frequently forgotten or neglected parts of your build. Typically, they throw a mechanical room in some small vacant closet somewhere, kind of a forgotten realm in your building, but it's also the number one most important part of your building. So, due diligence is the first place to start. Understand your design and your build, and understand that you have to heat water and everything else, and that's going to happen at some location in your house. If you throw it in your crawl space or you throw it in your attic just haphazardly, just expect you're going to not like it when you need to service these appliances or do something in the future to these appliances. Today we are in a 3,000 square foot shop that is going to more or less be fully coded to living standards. So we have a bonus room that's upstairs, that's a standard bedroom. We have a full bathroom without a shower down in here. The shower's actually up in the room upstairs. And then we have an office that's all heated on its own thermostat. And we are 2x4 construction inside of a steel frame building. We have our R19 insulation, 2 layers of it in the walls, and we are just doing the rough in right now on this bathroom, and specifically this one wall. The reason why we're doing just the one wall is because I need to hang my boiler to tie it in before I can run my water pipes. I like my water pipes to be exposed on my appliance side so I can monitor them or tap into them in the future if needed. But on the bathroom side, which is where my toilet is going and the urinal is going right here, I don't want any water pipes or anything exposed over in this area. So before I can run the water lines through these walls, I need to land my boiler. And the boiler is a combi unit, meaning it's the hot water heater and the boiler in one. So I need to get the hot water lines and everything dialed in, brought into the wall. Then I'll go ahead and rough the rest of this in. So this is going to get sheeted. And before I sheet it, I wanted to bring up some points for people who are doing their mechanical rooms. The first thing is think of futures. And what I mean by futures is anything that you think you're going to get in the future, go ahead and wire for it. Go ahead and plumb for it while you were at this point. It is so much less expensive to run a piece of 12 gauge Romex in the wall for a future appliance that you might or might not ever get, but it's there if you do. I say that because I see time and time again people like, man, I really wish I had, an air compressor over here, but I didn't wire for it. Or I wish I had a dog blower for my dog wash station that I'm putting in, but I didn't wire for it. So just think about the futures. Put more outlets than you need and put more circuits that you need. And what I mean by circuits is a home run. So if anybody out there is new to this game, what is referred to as a home run is something that goes directly to the panel, directly to the appliance. That's a home run. So if I refer to this wire here as a home run, that means that there's only two ends of this wire. This end that I'm holding and the other end that is down in the power panel. That is a direct dedicated circuit. With that being said, all appliances such as boilers, hot water heaters, stoves, ovens, washing machines, microwaves, refrigerators, freezers, everything like that, they need a dedicated home run by code. So think about big appliances. So what I did here on this particular furnace, this boiler, I like to mount a surface mount handy box that I put an SSU on, which is a disconnect switch. Another thing by code, if you're here working on this appliance, you need to have your disconnect within line of sight. So think about that too. I like to stub mine out of the wall using a staple at a position won't move. And this will be a surface mounted box that the Romex will go into, and then I'll run out from MC to the boiler. So that is, to me, the cleanest way to do it. A lot of people just put an outlet down there somewhere and they just dangle a cord and plug it in. If you're building your mechanical room, take some pride with it, because this is something that you're going to see and you're going to deal with for the entire time you live at this property. Or if you go to sell the property, that's one of the first things that inspectors will really dig down on and try to crack you on, is making sure that everything in your mechanical room is up to date, not a fire hazard, and is to code. So build the code. Code is there for a reason. Try not to ignore it. In fact, if you're a do-it-yourselfer, I highly recommend that you go ahead and buy the code books and have them to refer to, because it's a good guideline. It's not a guideline, it's the law. So build the code. With that being said, what I have here looks kind of haphazardly located is my backing blocks. It looks like a scab job, but it's really not. Every one of those backing blocks is in a position for an appliance that I need to hang on the wall. And I have my boiler hanging right here, and it's very heavy. So you want to notch the 2x6s for your boiler to hang on. Now down here on the bottom, they don't need to be notched because this is just going to bolt the bottom of the boiler against the wall so it doesn't dangle or flap around. These 2x12s that are here, this is where my steam lines, my boiler lines, not steam lines, are going to attach to the wall with brackets. And I want to have a good wide space for it because I don't know exactly where the plumbing is going to land. And then over here, we have a whole water filter bank that's mounting on the wall. And they're not light, so they need to be good and rigid and not going to fail. They're all screwed in, multiple locations, and toe-nailed with nails. The other thing is, too, my expansion tank. I like my expansion tank to be off the ground. So the expansion tank shelf's going to go here, and then I'm going to drop rods from the ceiling to hold the shelf up. So my expansion tank's right off the ground. So another tip is after you put your blocking in, is to go ahead and write on them with a Sharpie the measurements on where they're located. So 40 inches from the ground to 55 inches, 4 foot from the wall, 64. I marked everything, and I will take a good high definition photograph of this wall. And then after I sheet it, I will know everywhere I have blocking. Because oftentimes you sleep and you forget where you put your blocking, and you're sitting running around with a stud finder or your knuckle trying to find where they're at. So this saves me a ton of time. I've learned this trial and tribulation. Just take a good photograph and save it in your phone or save it wherever you save it to refer back to. Another thing that I've learned, which I find incredibly handy, I learned it from a drywaller when I was working as an electrician. This is something that I found extremely handy. So when you're coming in to sheet this stuff, obviously you have cutouts. For your plumbing, for your electrical boxes, multiple per sheet is a pain in the butt. So what I do is when I rough these in, I take the measurement of the stub from the wall and from the floor up. And then I carry my measurements on the floor, telling you 10 and a quarter over and 15 and a quarter up. I got a 2-inch hole that I got to bore for that pipe. And then right here, I need 3 half-inch holes at those measurements for my lines that are going to stub out from that sheet. Same with my electrical boxes. And if you're doing drywall, you would literally put your sheet up, you would look at that measurement, you'd pull a measurement, and then you drop your router in and it cut this box out. But since this is OSB, I'm going to have to do the cutting on the bench. But those are tricks that I've learned to help your rough-in stage. Another thing is, too, that people forget frequently is thermostat wire. Wherever you're putting your furnace, whether it's HVAC or whether it's a boiler or whatever it may be, you need to have control for it so you can turn it on and off. So I plan on doing 3 zones in this shop, even though right out of the gate I'm just going to be doing 1. I am roughing in for 3 because I rough in for futures always. So I always recommend to run an 18-8. That's an 8 conductor thermostat wire. 18.5 is probably sufficient for most people. However, as more and more HVAC products are becoming smarter, they require more conductors. For example, if you're going to run a heat pump in the future, or you're going to run a multi-stage furnace with AC also, you're going to need more control wires. The cost is nominal to get a roll of 18.8 and just run 18.8. So I've been running 18.8 for quite a while, and yeah, most of the time I'm tucking away 4 wires in the wall, but it's not an issue because those 4 wires will be there ever if you upgrade you're future proof at that point. So I also learned this while I was wiring as an electrician to coil up a little bit of slack and in your thermostat. That way, if your thermostat wire ever gets damaged, you can kind of pull some through, which they frequently do get damaged. Another method of doing that is something like this, where you put a coil spring in, and then you can pull that coiling out. A lot of inspectors will kind of ask about that, like what's going on. So just make sure that your coiling is less than 1.5 inches and it's not going to get hit by a nail with a staple on top and a staple on bottom. And most inspectors will pass it. So another thing about futuring, you need to make sure before you put your sheeting up, especially in your mechanical room, that you have good nail plates so you can't go through your plumbing. And also mark the height of your plumbing. As you can see there, I put 39 inches off the ground. That one's 6 to 8 inches off the ground. Put that in there, and you can mark that somewhere on the wall so you know that those pipes won't ever get hit. I also, of course, like to put my piping as deep in as I can. 1.5 inches is kind of standardization for not being able to hit something with a screw or a nail. That's hard to do with, say, 1.5 inch pipe in a 2x6 wall. You just don't have that much space. Code says 5/8 of an inch is as close as you're supposed to be able to get with piping and still have the stud's integrity. This piping, I don't like to notch. I like to bore holes since it does still keep my integrity of my stud in position. And sometimes it's really hard to get that piping in those holes. I've had people ask me before how I do that. And how I do it is I heat that pipe up, and I get it to where it's kind of like taffy, and then I can kind of feed it through. And then as it cools, I just make sure to stiffen it to where it's straight. So I don't know, that's a tip people probably already knew, but if not, there you go. The other thing is with futuring is make sure that you have home run circuits for any futured appliance that you might think you need. For example, right here, this is a dog wash box that I'm putting in for a blow dryer for my dogs. This is going to be the dog wash sink, and eventually I might want that blower, so I put one in for it. Also have one out there for a AC unit, swamp cooler, the plant running. And then here's your low voltage wires. So these are all low volt. They run in different holes than your high volt. And I put in low voltage lighting a lot of the times. So I run my 18.4 for an overhead LED bar. I run my 18.4 for a glycol pump for my boiler, which will go over there. And I run my 18.4 for my toilet flusher because it's one of those sensored ones that fires on its own, and it has to have 12 volt. And then all of that stuff comes over here to where I will land a low voltage panel, and I will drop from 110 with the transformer down to 12. So I won't have a chance to pull those through again. So I don't need those for a long time, but they're in the wall already. I also have a 12 volt wire that I ran to the other side just in case I ever decide to put an automated dog door in for my kennel. So think about futures. They're cheap. They're inexpensive to do right now. So go ahead and do it. This side over here, this side is not going to be finished for a minute because I'm doing this in multi-phase, like I said. So this wall will get sheeted. I'm going to put a boiler on. I'm going to land my hot water lines to it. Then I'm going to put my hot water lines in the walls. And then I'll finish the rest of this rough-in phase. But definitely put some time and some energy and some thought into your mechanical rooms. That is the one thing that I can say that do-it-yourself people are not the best at, is thinking about all of the mechanics in their building and in their house. A lot of times people, it's like an afterthought. They oftentimes forget closet space and they forget their mechanical room space. I always when I build my own stuff, I put my mechanical room in the center of the building or of the house, because centrally located is the most ideal location for your mechanicals. You can run home run water circuits to each shower. You can run home run power circuits to everything, and you save yourself a ton of time and money. There's nothing worse than having a house that's huge and the bathroom's the furthest point from the mechanical room, and you open up your hot water faucet and it takes a half an hour to get hot water over there because it's so far away. And then you're trying to put in a circulator pump and everything else so your hot water comes to you quicker. Which is a waste of energy and a waste of time. If you were just to think it out in the beginning, you would have put that utility room somewhere centrally located. Same with HVAC ducts. If you're so into HVAC stuff, which I highly recommend hydronic, but HVAC ducts is the same way. You need to have a central location. So thanks for watching my video. I hope some of this made sense, maybe enlightened some do-it-yourselfers that are out there. Oh, one more thing that I almost forgot. Make sure that you have as many of your appliances on hand as you can before you do the rough in, because appliances are kind of standardized, but not really. For example, some washers and dryers go under shelves, some stack on top of each other, some, boilers have fittings in the outside, left, right, bottom, whatever. And then, like, for example, toilets. Even a toilet has a standardization of 12 inches flange from the distance of the wall. However, I got a commercial toilet that requires a 1-inch water line, and I roughed in 12 inches for it. Well, I got the toilet, and it was an 8-inch back spacing. So my toilet was off the wall by over 6 inches, which really looks stupid. So I ended up building a subwall here. However, if I didn't have that toilet on hand when I was roughing in, I would have roughed it in incorrectly. I wouldn't have run a 1-inch home run to it because I would have never thought that it needed 1 inches of water. I wouldn't have ran a 12 voltage wire for the flusher. And same with the urinal. I wouldn't have run 2-inch waistline to a urinal. I would have run 1.5 inches. So the more appliances that you have on hand, the better off you're going to be, because you will know exactly what your appliance needs. Another thing is too, for like the hydronic pumps for my boiler, I'm planning on running 3 of them. So I put 3 future wires in the wall to go around over here and stub out back over here, which is only the distance of like 24 inches, but I don't want MC on the wall if I don't have to. I want everything to be tucked and rolled and hidden nicely. So just think, put your brain to work, and make this something that you're proud of. And I promise you will be very, very, very happy you did. Thanks again for watching.